Good afternoon. This is just an illustration of the hype around microservices, but this is not my presentation. This is the one. So again, I'm Paulo Merson. I work for the Brazilian Federal Court of Accounts, TCU. It's the acronym, not the Texas Christian University. And here's the picture. Nice place. And this is our goal. We'll try to define microservice as hard as it sounds, and discuss the trade-offs, what you gain and what you lose. Well, unfortunately, there's no consensual description or definition of microservices. We understand it's an architecture style, but think of REST. It was nicely defined in a PhD dissertation. And with the constraints, and it was very clear. For microservices, quickly became a buzzword, and then all of a sudden, a lot of people are writing about it, and it's not clear what it is, what kind of style that is. I mean, there are already descriptions on the web of microservices as an architectural style. Well, let's discuss. So here's one widely referenced attempt to define it by James Lewis and Martin Fowler. It says, the microservice architectural style is an approach to developing a single application as a suite of small services, each running on its own process, and communicating with lightweight mechanisms, often HTTP. And we can add messaging. These services are built around business capabilities and independently deployable by fully automated deployment machinery. But again, you go to the web and you Google search for microservices, you're going to find a lot of things, and it becomes fuzzy. Consultants are selling their services around microservices. Vendors are rebranding their products to mention microservice support. So what does it really mean to create a microservice? So am I doing it right? Am I really creating what people are calling microservices? And here's the problem. If you go out there to find out if you're doing microservices, you may get this idea. Microservices should have few lines of code. Some say between 10 and 100. That doesn't quite make sense to me. That doesn't characterize the style. Especially because when you develop a REST service, let's say, you're going to create a REST controller class, which will call other classes, which will call other classes. Altogether, when you deploy it as a microservice, you have far more than 100 or 300 lines of code if you have reasonable functionality in that bundle. They say, well, the web microservice should be small enough that you can feed the development team with 1 or 2 pizzas. Not quite architectural. And if you get your developers fresh out of college, you're going to have very small microservices because they're quite hungry. Microservices should offer coarse-grained operations. Granularity of the operations in a service contract is very important. And there are trade-offs to consider: composability, performance. And it's very hard to say, hey, this is the right way. You need to ponder the trade-offs for each service. All right, so I don't think that can characterize what's a microservice. They should not participate in complex service compositions. So as a general rule, it's debatable. Microservices should be monitored by sophisticated logging and monitoring infrastructure. So here's where it becomes confusing because it's a buzzword. Many people are saying, hey, this is a good practice. It belongs to microservices. And all of a sudden, microservices became a magnet for good development and operations practice. So using DevOps is part of microservices, right? Creating modular classes, yeah, that's necessary for microservices. Having good tests, automated deployment, that's good for microservices. But that doesn't characterize the style. And the list goes on. Be developed by teams split around business capabilities per I just learned before lunch, inverse Conway's law, right? That's another aspect. Yes, so that's the inverse Conway maneuver. That's also something that people have said, oh, this is microservices. Be run by the team who built them. Well, this is a DevOps practice. Is this a good practice? Yes, it is, but not for all cases. And does that characterize microservices? I don't think so. That's an independent idea. Manage their own databases. This is one that will help you with autonomy. But as we're going to establish later, it's a good idea in some cases, but it's not what characterizes the microservices style. Match DDD bounded contexts. This is something we're trying to do in our organization. But DDD is much older than the idea of microservices. And if you're not doing DDD, what do? So again, it's an idea. It's applicable to microservices, but it doesn't characterize the architecture style. And some say microservices must be dynamically discovered. You need dynamic binding. Also questionable. There are trade-offs. And they should be small enough to be rewritten in 2 weeks. Yeah, so very subjective, not very architectural. So anyway, let's try to understand what a microservice is. But before we get there, we need to look at the other end of the spectrum. And that's called the monolithic model. And it's funny because monolithic became a bad word. And at work, we talk about SOA. We have our SOA project, and we were saying a couple years ago, we established that, oh, we need SOA governance. But governance is a name that people are afraid of, especially developers. And so I'm more of a tech person. Yeah, you don't like to be governed. You like empowerment, right? And now governance was already a bad word, and now they came up with monolithic governance. So have to run away. In fact, in our organization, when we first talking about governance, we had people rolling their eyes, and at some point we began calling it the G word to simplify matters. But what is the monolith anyway? So here's the idea. All services within a given application or software system are packaged together into one deployment artifact or deployment bundle. So you have your SOAP services, REST services, plus your web components, other classes. Everything that is part of a given application is packaged together. And that deployment artifact is the monolith. And this is the picture I have on the far right. The yellow box is the monolith right there. A small change in any of those elements requires redeploying the whole monolith. All right? And this approach has been the norm since the beginning of multi-tier web applications and SOA, since 2001, or a little earlier. And what is the microservice approach? Well, here, the architecture style actually dictates that the deployment unit should contain only one service or a small set of cohesive services. This deployment requirement is the distinguishing factor for the architecture style. It has deep consequences and will encourage you to employ other independent ideas, techniques to make it work. But the architectural style, an architectural style has design constraints, and this is the key constraint that defines what a microservice is. But just like different styles, we have variations. So on the left side, you see a variation of the monolithic approach. Over there, we broke up the deployment bundle into two. One has only services, say your REST services, and the other bundle up on top has all the other components that are part of the same application. On the right-hand side, that's a variation on the microservices approach where I introduced containerization. Okay? So you have the microservice deployment bundle, but it's rebundled with the runtime environment, and then you have yet another level of deployment artifact, which is your container, okay, created according to some container image appropriate for that microservice, and it runs on a container engine or runtime environment. Now, when you design a microservice, the style itself doesn't dictate specific technologies, but I think it's safe to say, as of today, you're expected to use HTTP for communicating with the service, following the REST style, or asynchronous messaging or events. What about SOAP? From what I've read and heard about microservices, SOAP is not a good fit. Well, we can discuss why later on. We don't have time right at the moment. What else? Microservices should be designed according to SOA design guidelines. That's an open statement because we don't have time to explain the design guidelines, but there are well-known and established design guidelines or design principles, and they are applicable to microservices. And it's very critical to find the functional context for a microservice, to define functional cohesion. That's the term I heard before lunch in a talk. And that's when, for example, an idea like domain-driven design comes into play. It helps you, it guides you to find the right place where you cut your microservice boundaries. Now, microservice is not a good alternative in all cases. As always, us architects, we need to consider the trade-offs. And that's the second part of our talk. I'm going to go over a few pluses and minuses of microservices. Benefits. Deployability, that's a clear one. You get more agility to roll out new versions of a service because your build, test, and deploy cycle is shorter. You get also flexibility to employ different configurations for each microservice. So when you're, let's say you want to configure a security mechanism, that security mechanism gets to be configured per deployment artifact through some deployment descriptor or property element. Now, if you have the monolith, that configuration is for the entire monolith. If you break into small bundles, each bundle can use a different configuration, right? Each microservice can use a different container image, as we mentioned before. Scalability, yes, again, each service inside the microservice gets to be scaled independently. So if you have 5 services in your solution, 5 REST services, one of them has a much higher load of requests. If it's in the monolith and you want to say, oh, because of that service, I need to use a cluster, I need to go to the cloud, or use a grid solution, well, you have to set that up for the entire monolith. If you have microservices, you can pick just that microservice that has a higher load and configure clusterization for it. And of course, these characteristics of deploying microservices make them a good match for the elasticity of the cloud. Elasticity is the cloud term for horizontal scalability. What else? You gain in modifiability. You have more flexibility to use different frameworks, libraries, data sources. You can configure and use different things per microservice. Microservices, because of the way they run, they're packaged and run, they need to be designed to be more loosely coupled, right? Also, you can introduce dynamic discovery and binding. That gives you another level of interaction, helps with modifiability, gives you flexibility. What about availability? Well, this is a minor point, but when you roll out a new version of a microservice, you need to replace that small deployment artifact in the runtime environment. That's much quicker than rolling out a new monolith. That's when you need to bring down the monolith, replace the big monolith file, and then restart it. So shorter downtime for microservices. Application development management for project managers. The idea of microservices help because you have smaller teams. The teams are empowered. They're creating their own thing, their own microservices. So you have smaller projects to manage. So management of the development effort is simpler because it's broken into different microservices. Design autonomy, that's one of the benefits our software architects should like because each microservice is independent. You have flexibility to use different design patterns, even design different technologies, different frameworks. You can redesign and redeploy your microservice independently. Reliability. this is also a minor issue. Well, let's say you have a REST service and unfortunately it has a resource leak. If it's part of a monolith, that resource leak can use up all the memory on the server and it can bring down the entire monolith. If it's inside a microservice, it will compromise that microservice alone and its consumers, but not the entire monolith. So there's a benefit there. And here's the other side, the challenges of using microservices. These are the things you need to remember if you get bit by the microservice bug. Ask yourself about these challenges in your specific situation. Deployability. Well, it turns out that there's a benefit, as we mentioned before, but there's a challenge. You have many more deployment artifacts. You need more deployment jobs, scripts, transfer areas, configuration files, more elements of the deployment procedure. That's why, by the way, that definition that we mentioned said you need automated deployment machinery, right? Performance. Here's the thing. When you have a monolith, you have your, say, REST services all inside, plus the web components, other classes that call services, and they are all inside the same monolith. Depending on your runtime environment, your runtime platform, it's possible that a call to a REST service that is inside the monolith gets optimized so that you avoid a remote call. So when you break that same monolith into multiple microservices, you don't get that possible optimization. So you may have a performance decrease. There's also the situation where you use dynamic discovery, in which case the registry lookup, that's an intermediary, one more step, it's a performance overhead. Memory use. Well, typically there are some classes, utility classes, that you need in any of the deployment files, right? They are common code that is shared across applications or services. With a monolithic deployment, you have one copy of those classes in each monolith. Now you need one copy of those classes in each microservice. So the overall memory footprint increases. Modifiability. We're going to talk about autonomy in a minute, but some mechanisms that are often used along with microservices, such as eventual consistency and asynchronous calls, add complexity to your design. So that's a challenge with respect to modifiability. Also, when you have a REST service that is part of a monolith, it's likely that some of the consumers of that REST service are inside the monolith. If you need to change that contract, you need to change the consumers. Well, depend on the changing, but let's say you need to change the contract and you need to change the consumers. If they're deployed together inside of the monolith, then they are redeployed in lockstep, right? So that makes it easier. If each deployment is independent, you need to be more careful. You need more governance when you change, you need more G-word when you change your microservice contract. Testability. Yeah, so soon enough you realize that automated tests, integration tests specifically, are harder to set up and run when you have multiple microservices running on multiple distinct deployment environments. And managing operations, taking the operations perspective here, is more challenging as well. In our organization, when we first mentioned the idea of, oh, let's go to microservices, the operations people, when they realized, oh my God, this is going to be a lot of trouble for us, and they foresaw the issues ahead, and they were concerned with the amount of effort to manage everything. So be aware and be also conscious that they're concerned very much with that. Availability, but minor issue, but if you use dynamic discovery, make sure you design your registry so that it's not a single point of failure. And that's the last challenge listed there, but also the most controversial one. So here's the thing. When you have a single monolith, again, it's likely that some of the consumers of the services are inside the monolith. And you have that optimization, they're all together, they're running close by, okay? So if a given service consumer is up and running inside the monolith and it's calling a service inside the monolith, they know they're right there available, they're running on the same environment. Now you split the same monolith into several microservices. All of a sudden, the service consumer calls a service and this service is deployed elsewhere in a separate bundle. That solution right there, because you split it into independently deployed elements, lost service autonomy, okay? So all else being equal, if you simply split a monolith into microservices, you will see a loss in service autonomy. Now, is that a big problem? Well, if you don't pay attention to it, it might be. But because of this difficulty, since the beginning, all of the people writing about microservices have been proposing several clever solutions to improve your service autonomy. And there's a last bullet that mentions transactional boundary. If these calls involve distributed transactional transactions, that's a big issue. So one thing that you should do when you're modeling your solutions in general is to avoid distributed transactions, right? If you're going with microservices, that's a no-no, a clear no-no. So how do you avoid autonomy issues? Different techniques available. You can use data replication plus eventual consistency. And that's why a lot of people are saying, hey, with microservices, you should have, each microservice should have its own database. Well, that idea is not specific to microservices. This is a well-known design pattern. Was at least as far as 2009, I know there's a description as a design pattern in a book, okay, which was created to improve the autonomy of source services in general, okay, and now it's being prescribed for microservices so that you don't have that autonomy issue, okay. Event-driven architecture, the idea that instead of synchronous request-response interactions between services, you have them communicating via events. So they're more loosely coupled. It's more challenging to design, but you gain in autonomy, all right? And in the talk I attended before lunch, we had an example of several styles that could help to make your architecture evolutionary, amenable to change. And there was one of them was microservices. In my opinion, it's not microservices that makes your that gives your architecture this level of variability. In that scenario, it's event-driven architecture. So you say, let's say you have an event which is purchase order created. So you, instead of having a controller kind of service that will call this and that functionality when a purchase order is created, you have that element sending out an event to a publish subscribe kind of mechanism, purchase order created. Then if you have new functionality, if you want to change your architecture, if the business rules changed and you need to do something else because there is an event for purchase order created, you just add a subscriber. The publisher doesn't need to change. Any of the other subscribers, they don't need to change. So event-driven architecture, that's a technique, a design technique, a composition approach, I can say, service composition approach that helps with making your architecture evolutionary, per se. Command query responsibility segregation, that's another idea, CQRS. Yeah, I won't have time to explain, but there's office hours on Thursday for me. Ask me how. I have my email address at the end too. Aligning microservices with DDD bounded contexts. That's a clever idea because it goes up to modeling the business entities. So you start doing it right, allegedly, but you start supposedly you're doing it right from the modeling phase. When you're modeling your business entities, you break them up into boundaries, okay, where you define some transactional consistency boundaries, and you know what elements are supposed to interact in a sort of request-response, ACID kind of transactional way, and you know which business entities can interact in a more, let's say, event-driven, eventual consistency kind of way. So the modeling already thinks about that, and then you have a sort of a ruler that can help you to establish the right size for your microservices, the right granularity. Anyway, these techniques have been often associated with microservices, but they're not inherent to microservices. They actually can prevent autonomy issues that could arise from this simple idea of splitting services in a monolith into microservices. So just a few links. Interesting read about microservices. And I don't know, I think we have a couple minutes for questions. Thanks.
So Garner talks about mini-services as well. Can you contrast mini-services with microservices?
Well, you have to say more about mini-services.
Okay, what their definition is clearly microservices are hard to implement. So what they say is if you really start slimming down your SOA services to something not quite a microservice, and it's not as independent microservice, but you get something better than core SOA services. That's the best definition.
So if you think of, when you first read about microservices, they look like, oh, this is going to be very granular, very small. And then you realize that in practice, and we're going through this process in our organization, we have been doing monolithic kind of deployment for a couple of decades now, and now we have 3 projects that are now playing with the idea of microservices, and we realize, no, it's not that fine-grained. So maybe it's closer to mini service. And we're taking that idea of modeling using DDD, and we are also in agreement that we can use the idea of a bounded context, which is the DDD idea. And guess what? Bounded contexts are not that small. So I think it's like you read about microservices and you have the feeling that they're going to be very small, but when you get to do it, you realize they're a little bigger than they were supposed to be, but that's the way it has to be so that it doesn't give you much headache and autonomy issues. So maybe mini service is the actual thing that we end up building in many cases.
A question on your mapping microservices to DDD. Are you able to then, in practice, split up the database apart, or does it then work on the same database?
So in our organization, we have had a centralized database with centralized data administration, data modeling for decades now. And in this new project, one of the 3 that I mentioned, the proposal there is each microservice will have its own database. And that we're kind of breaking some paradigms in our organization with that project because we want to have that level of autonomy. So if you go back to DDD, if you're familiar with DDD, the idea there is you have a database per bounded context. And inside the bounded context, you have several aggregates. Now, each aggregate then should map to a given REST service. Okay? So within a given REST service, you have one aggregate, possibly multiple business entities or entities. So, but altogether, they form a bounded context, and per bounded context, you can have a separate database, and then with a synchronization mechanism. Now, is this going to work in our organization? I will tell you in a few months' time. At the moment, we're going with the wave there. We have been discussing the trade-offs, but we're going to try it. All right, time for the next section. Thank you very much.